Alright, so in this section, we get two more congruence criteria. They are angle, side, angle, which is side, angle, side, obviously flipped inside out, and angle, angle, side. So we now are going to know that as long as we have two angles, then and one side, it doesn't matter whether the side we know is in between the two angles or outside of the two angles, then that's going to show you that the two triangles are congruent. So here's what angle, side, angle looks like. There's an angle, and that's an angle. Those are congruent. These two angles are also congruent, and then the side in between are congruent as well. So that sets us up. Here's an application of the angle, side, angle congruence criterion. Technician is putting in these cables, and the two cables need to be the same length. If these two angles are the same, do we know that the cables are automatically going to be the same length? And I guess that the answer is yes. Because why? Oh, because this angle is 90, so that angle is 90. This side is obviously congruent to itself, so angle, side, angle, angle, side, angle, so everybody's winner. And math is terrific. Okay, so first question here is Jkl Congruent Mn? So Jkl Mn, so I've got an angle, and I've got an angle, or I've got a side, and I've got a side, and then I've got an angle, and I've got an angle. So I'm going to go yes by, whoops, not side, angle, side, that was so yesterday. Angle, side, angle. How about this one and PQR? And in this case, the answer would be not necessarily, because I know that this angle and this angle are the same, so that's fun. And I know that this side and this side are the same, so that's good. But this angle is essentially like this one on the triangle. This is like angle, side, angle, and this is angle, angle, side. And they have to be the same. So no, once again, they could be, but we don't know from the information that's given. But now we do, because now we're told that angle, angle, side is a way that you can show that two triangles are congruent. In other words, the side that you know doesn't have to be in between the two angles, and the reason for that is pretty straightforward. We know that the angles in a triangle always add up to 180 degrees. So if these two angles are the same, then that means that this angle is going to be also the same as this angle, and then now we're back into the angle, side, angle situation. So angle, angle, side is just kind of a offshoot of angle, side, angle. Okay, so these two triangles are congruent by angle, side, angle. These two triangles are congruent by our old friend side, side, side. Let's not forget that. These two triangles are congruent by our new congruence criterion, angle, angle, side, angle, angle, side, angle, angle, side. And again, we could say, that these two angles are the same, and then use angle, side, angle, so those are pretty interchangeable. And then these we don't know, because this angle is in between these two sides, and this angle is not. So that is no bueno. What additional information would we need to show that these two are congruent by angle, side, angle? Well, I've got angle, side, looks like I would need an angle. So I would need to know that angle E is congruent to angle B. How about if we wanted to do it instead by angle, angle, side? Well, then I would need another side, but not the one that would include this angle. So I would need to know that this side here and this side here are congruent. So FE would need to be shown to be congruent to BC. Okay, a little algebra going on here. So we now have congruent quadrilaterals. That's the same thing as congruent triangles. It doesn't matter how many sides we have. But we're trying to figure out the value of x, so I guess we just need to figure out which side this one matches up to on this triangle right here. So you can kind of see from the drawing, but if you want to be technical and not be tricked, this is side EH. So E and H are the first and the last letters in this quadrilateral, so they're going to match up with side AD because that's the first and the last letters on that other quadrilateral, which is, you know, what you could see just by kind of rotating that in your brain. But that means that 2x minus 3 has to equal 9, which means that x equals 15. Just kidding, just making sure you're paying attention. That would be x equals 6. Okay, all right, so 2 new triangle congruences, some problems to work on, practice those ideas.